Hello everyone and welcome again to my How To Education channel. As I promised you on Friday, we start derivatives today and we'll speak about its general rules. After watching this video, don't forget to leave me your feedback. Before trying to ace derivatives, let's see what a derivative is. We will start by looking at the function y equals f of x. If we're asked to interpret it, we would say that y is defined to be a function in terms of x, and that the value of the function y will change if the value of x changes. The rate at which the value of y changes when the value of x changes is called the derivative of f of x. You might be telling yourself, okay, I now know what a derivative is, but how do I interpret the question and know that what they want is for me to find the derivative? For that, you need to know how a derivative can be denoted. If y equals f of x, then the derivative of y can be denoted by y prime f prime of x dy by dx, the gradient formula of y equals f of x, or the slope of y equals f of x. In other words, if the question is find y prime or f prime of x, or dy by dx, or the slope of y equals f of x, or the gradient formula of y equals f of x, it means that it's asking for the derivative of y equals f of x. The process of finding the derivative of a function is called differentiation. Since there is an infinite number of functions within the scope of math, we need to set different rules to find derivatives. The first rule concerns the functions of the form f of x equals x to the power n, where x is the variable and n is a real number. As for example, f of x equals x to the power 100, in which x is the variable and n is the real number 100. All of the functions of this form will have their derivatives in the form f prime equals n x to the power n minus 1. If we use the previous example, f of x equals x to the power 100, then f prime of x equals 100 x to the power 100 minus 1, which is equals to 100 x to the power 99, such that n is 100 and n minus 1 is 99. The second rule is more or less like the first, but with the difference that it concerns functions of the form f of x equals cx to the power n, where x is the variable, n is a real number, and c is a constant. Like for example, f of x equals 20x to the power 100, in which x is the variable, c is the constant number 20, and n is the real number 100. All of the functions of this form will have their derivatives in the form f prime of x equals c times n times x to the power n minus 1. If we use the previous example, f of x equals 20x to the power 100, then f prime of x will be 20 times 100 times x to the power 100 minus 1, which is equals to 2000 x to the power 99. Now, let's move on to some exercises to make sure that these two concepts are well stuck in your mind. Take a minute to read these questions before we move on to answering them. And take another minute to read the following. If f of x equals x to the power 3, then according to the general formula for finding derivatives, f prime of x equals n x to the power n minus 1, where n is 3 and n minus 1 is 2. In this case, f prime of x equals 3x squared. If f of x equals x to the power 1 over 4, then according to the general formula for finding derivatives, f prime of x equals n x to the power n minus 1, where n is 1 over 4 and n minus 1 is minus 3 over 4. In this case, f prime of x equals 1 over 4x to the power minus 3 over 4. If f of x equals x to the power minus 4, then according to the general formula for finding derivatives, f prime of x equals n x to the power n minus 1, where n is minus 4 and n minus 1 is minus 5. In this case, f prime of x equals minus 4 x to the power minus 5. If f of x equals x to the 3 over x to the 35, before finding the derivative, we must rewrite it using the form f of x equals x to the n, such that x is the variable and n is a real number. Thus, f of x equals 1 over x to the power 35 minus 3, which is 1 over x to the power 32, which is x to the power minus 32. Thus, f prime of x will be minus 32 x to the power minus 33. f of x equals x to the power 3 times x to the power 35. Before finding the derivative of this function, we must rewrite it using the form f of x equals x to the power n, such that x is the variable and n is the real number. In this case, f of x becomes x to the power 35 plus 3, which is x to the power 38. And f prime of x will become 38x to the power 37. In order to convert the fifth root of x cubed to the form f of x equals x to the n, we must follow the formula the nth root of x to the I equals x to the I over n, such that I is the real number inside the radical and n is the real number outside. So f of x will become x to the power 3 over 5, and f prime of x will become 3 over 5 x to the power minus 2 over 5. f of x equals 1 over x to the power 35. In order to convert this function to the form f of x equals x to the power n, we must follow the formula 1 over x to the power a equals x to the power minus a. In this case, f of x will become x to the power minus 35, and f prime of x will become minus 35x to the power minus 36. f of x equals 1 over the fifth root of x cubed. Before finding the derivative of this, we must rewrite it using the form f of x equals x to the power n, such that x is the variable and n is a real number. In this case, f of x becomes 1 over x to the power 3 over 5, which is equals to x to the power minus 3 over 5. So f prime of x will become minus 3 over 5 x to the power minus 8 over 5. f of x equals x to the power 38 over x to the power 35. Before finding the derivative of this function, we must rewrite it using the form f of x equals x to the power n, such that x is the variable and n is a real number. In this case, f of x equals x to the power 38 minus 35, which is x to the power 3, and f prime of x is 3x squared. If f of x equals 20x3, then according to the general formula for finding derivatives, f prime of x equals c times n times x to the power n minus 1. In this case, f prime of x equals 20 times 3 times x squared, which is 60x squared. f of x equals 9x to the power 1 over 4. Then, according to the general formula for finding derivatives, f prime of x equals cn times x to the power n minus 1. In this case, f prime of x equals 9 times 1 over 4 x to the power minus 3 over 4, which is 9 over 4 x to the power minus 3 over 4. If f of x equals 8x to the power minus 4, then according to the general formula for finding derivatives, f prime of x equals 8 times minus 4 x to the power minus 5, which is minus 32 x to the power minus 5. f of x equals to 2x to the 3 over 10x to the 35. Before finding the derivative of it, we must rewrite it using the form f of x equals cx to the n. Thus, f of x becomes 1 over 5x to the power 35 minus 3, which is 1 over 5 times x to the power minus 32. And f prime of x becomes minus 32 over 5 x to the power minus 33. F of x equals 10x to the 3 times 50x to the 35. Before finding the derivative, again we must write it in the form f of x equals cx to the power n, such that x is the variable, c is the constant, and n is the real number. Thus, f of x becomes 10 times 50 times x to the power 35 plus 3, which is 500 x to the power 38. And f prime of x becomes 500 times 38 x to the power 37, which is 19,000 x to the power 37. F of x equals 2 times the fifth root of x cubed. Before finding the derivative of this, we must rewrite it in the form f of x equals cx to the n. Thus, f of x becomes 2x to the power 3 over 5, and f prime of x becomes 2 times 3 over 5 x to the power minus 2 over 5, which is 6 over 5 x to the power minus 2 over 5. F of x equals 18 over x to the 35. Before finding the derivative of this, we must rewrite it in the form f of x equals cx to the n, such that x is the variable, c is the constant, and n is the real number. Thus, f of x equals 18x to the power minus 35, and f prime of x is 18 times minus 35 x to the power minus 36, which is equal to minus 630 x to the power minus 36. At this point, we all know that 8 divided by the fifth root of x cubed equals to 8 over x to the power 3 over 5. And 8 over x to the power 3 over 5 equals 8x to the power minus 3 over 5. Thus, f prime of x equals 8 times minus 3 over 5 x to the power minus 8 over 5, which is minus 24 over 5 x to the power minus 8 over 5. F of x equals x to the 38 over 9 x to the 35, which is equal to x to the 38 minus 35 over 9, which is x to the 3 over 9, which is 1 over 9 x to the 3. Thus, f prime of x equals 3 times 1 over 9 x squared, which is 3 over 9 x squared, which is 1 over 3 x squared. After going over these two rules, let's go over their implications. First, the derivative of a function of the form f of x equals cx, where x is the variable and c is the constant, is always equal to c. Example, if f of x equals 2x, then f prime of x equals 2. If f of x equals 100x, then f prime of x equals 100. Let us prove what I said by setting f of x to be 500x. If f of x equals 500x, then we can write it as f of x equals 500x to the 1. Thus, f prime of x equals 500 times 1 x to the 0. Any non-zero constant or variable raised to the power of 0 will equal to 1. Therefore, x to the 0 is 1, and f prime of x equals 500 times 1 x to the 0, which is 500 times 1 times 1, which is 500. Second, the derivative of a function of the form f of x equals c, where c is a constant, is always equal to 0. Example, if f of x is 2, then f prime of x is 0. If f of x is 100, then f prime of x is 0, and so on. Let us prove what I said by setting f of x to be 500. If f of x is 500, since we can also write 500 as 500 times 1, f of x equals 500 times 1. As we have seen previously, 1 equals x to the 0. Thus, we can set f of x as 500 x to the 0. If f of x equals 500 x to the 0, then f prime of x equals 500 times 0 x to the minus 1, which is 0. Any non-zero constant or variable multiplied by 0 is equal to 0. Okay guys, this is it from math for this week, which probably relieves you a whole lot, right? Well, anyway, if you have reached the end of this, it's because the content is helpful to you somehow. If this is the case, then please do give your friends and acquaintances the opportunity to have access to these videos by liking, sharing, commenting, and subscribing to this channel. We will be continuing with more specific derivative rules next Monday. But before that, I will see you all on Wednesday with some economics content. Thank you so much.